the certifications are concerned, he has received several certifications like the Python for data science cleared certification exam, and which was conducted by IBM, and several other certifications similar to that. And also he has got more than 20 national and international publications in journals and conferences. And also he has attended many workshops and FDPs. With this brief introduction, I would like to invite Dr. Pramod Kumar Naik for handling the current session. Thank you.
Thank you, sir. Thank you for that warm welcome. And I wholeheartedly welcome all the participants. And let's go ahead and discuss on today's session. Specifically, our focus would be on how exactly we would be able to develop what is called as an industrial cybersecurity, okay, associated to IoT. So how exactly IoT is related, or such kind of case studies, and LoRa technology also, which is a long range IoT, which is basically used in industry. So are there any platforms associated to it? How exactly we would be able to use ThinkSpeak, Think Network. So these are the two different cloud setups where you can connect different devices and process different data on real time. So all these things we would be discussing during our session. So that is what is the highlight. So we'll be starting up with introducing what is meant by IoT. Followed by that, we'll also talk about LoRa communication. We would take a live example, like there would be a device which has been placed in Boston, which is in the Mathos office. From there, we would be capturing the live data. How exactly you would be able to do that on a real-time scenario, we would be discussing on that. Followed by that, we would also talk about how exactly long range, which is basically LoRa, long range, WLAN wireless modules are out there. We'll give an overview on it. How exactly you would be able to do sensor integration on LoRa wireless modules also would be discussed. Followed by that, as the network is concerned, like how exactly the cybersecurity would be developed, what is called as framework which is being used there. So that also we'll be discussing in. Followed by that, we would also demonstrate, like for an industrial application, say for example, they have to develop a simple IoT based face counting or something like that. So such kind of applications we would be talking about. At the end, we would also talk about the challenges associated to IoT. So this is going to be the highlight where I'll be covering this in 1 hour. So at any point of time, you have any questions associated to the slides, what I would be covering in, I request all the participants to go through the slides and whatever content I cover in, and put your questions into the chat box. At the end, once I conclude, before I conclude, I can go ahead and then address those questions one by one, and then I'll wind up with my session. So that's being said, let's go ahead and discuss. Now, everyone knows that what is meant by an IoT in colleges. What used to happen is that I generally go and ask my fellow friends out there who are attending the sessions, have you used internet, or have you used on IoT, or you have developed any IoT, or you have worked on IoT? So the general question is that yes, internet we have used, but when you ask about the question of IoT, they say no. But what is meant by IoT? Basically, IoT is nothing but Internet of Things, which generally refers to the scenario where there is a network connectivity, and then the computing capability is extended to the object, sensors, and everyday items, which is not normal considered as computer, where the devices are basically exchanging what is called as information. Right. So the Internet of Things describes the network of physical objects, that is basically the things that are embedded with the sensors. So you can just see that it might be a controller which is being connected with different devices, or it might be a mobile phone inside which there are different sensors which are out there. That data, okay, would be connected to what is called as internet, and then there is basically exchange of data between those devices, and this system is on internet, so it is called as Internet of Things. Now, once this is being discussed, whenever we talk about Internet of Things, there are different devices, so which are being basically connected to internet, where the person can have an user access to it, or basically it might be just an information access also, which can be in terms of manual entry of data, or it might be what is called as coming and developing an application which might be controlled remotely. Okay, it might be in terms of smart houses or smart homes, where you're having different devices which are being connected to different applications, or these days devices which we generally see in where we are extensively coming up with elder care, or it might be in terms of medical health care. So these are the areas where you can just see that IoT has been extensively used. These days we also see that there are when you go to Go Ibibo, or say Make My Trip, you book a bus and then they give the live tracking of the bus, right? So it might be in terms of transportation. And then we also have V2X communications also, which we call it as uh, vehicular communication system, or we call it as vehicle to everything communication, that is V2X. Consists basically there are different protocols there, so which is the first step towards what is called as autonomous driving. So these are the technology where people are extensively working on, and industries are also being working. Now, how exactly we would be able to work with this is that whenever, okay, okay. So whenever there are Internet of Things, there would be networks where you would be having devices which are being basically connected to what is called as uh, the network. Okay, and then there is ample areas which you look in here, is it might be in terms of consumer health, smart infrastructure, security, transportation, healthcare, retail, or it might be in terms of industrial or others. So if you look into these things here, IoT extensively used in all these areas. And as we talk about Internet of Things, basically Internet of Things is when you look into this particular slide here, say I have my mobile phone, okay, and I have different sensors which are available in my mobile phone, and then via what is called as a network, okay, or if I say it is an ESP8266 module, okay, which is also a Wi-Fi module, where I have different sensors, like you can call these as your child nodes. And basically to these you might be having different sensors, like this might be a microcontroller, this might be a microcontroller. So there, for one microcontroller, basically you can go ahead and connect three different sensors. So it might be capturing temperature, humidity, and pressure, and that data via what is called as a edge node. Okay, we also call it as the different embedded devices like an LoRa device. You can transmit that corresponding data into what is called as a cloud. Now, imagine the amount of data which we generate from one single mobile phone. Say if there are 7 sensors, in that if I consider one sensor, okay, if it is an accelerometer sensor, it will be having X, Y, and Z quadrant in it. Now, say if I'm capturing a live data from my mobile phone, say 2.65 seconds of data, okay, of one sensor, which is your accelerometer sensor, would, if I capture that live and put it into an Excel sheet, it would be having more than 7,245 sample points. Okay, so coordinate values it will give you. Now imagine that multiplied with 3, and then again multiplied with the difference. If there are 7 sensors and each has 3 quadrants in it, okay, and then imagine the number of people using mobile phone in India. Okay, so that amount of data is out there which gets stored, which forms your big data. But our technology is like we are using this big data, and then we develop or perform exploratory data analysis, and then develop business insights from it. So if whatever AI technology we talk about, it's basically these things, like it might be IoT, or it might be big data, or it might be an data scientist who actually develops your AI or ML application. They are related. Now, if I talk it in terms of what is called as Internet of Things, so you'd be having sensors like this, and then you'd be having a gateway. And via this particular gateway, you would be able to write this data into the cloud. Okay, and once you have written this corresponding data, you as a engineer, you would be able to perform exploratory data analysis on this cloud data and then deploy the algorithm. Okay, or if you want it to be automated, so you can go ahead and then deploy such kind of applications on these corresponding devices. Okay, now, whenever you talk about what is called as IoT, so this is one of the workflow where you can go ahead and if you're working on communication, I'll come to that part also. Like in one of the demo, I think it was for uh, Acharya Aeronautical, we had a device called as Adam Pluto, where you can capture the live data and then you can even track aeroplanes which are being flying in Boston, right? So such kind of things can be done in, and if you have a package of MATLAB, Simulink, and the RTL SDR, you would be able to do that. So to know that, this is one of the session which you can look into where they discuss a lot about edge nodes and then how exactly you would be able to come up with the technology associated to it. Now, from the point of our session today, I would be talking about different things, and at the same time, I'll demonstrate like how exactly you would be able to build blocks associated to IoT. Now, whenever you talk about IoT, the building block, when you see here, this is basically the things or devices, and then you would be having a communication model. Followed by that, whatever data comes in, that has to be managed in, and then data computing and interaction between the various devices which you have. As far as IoT elements are concerned, so to any device, embedded device, you would be connecting sensors and actuators to it. As far as networking is concerned, you can go with PAN, LAN, or WAN. And then the cloud infrastructure, this is where the cyber security team comes in, where your data is being captured, and then how exactly you can go ahead and then develop encryption based rooftop technology to withhold that corresponding data so that no one is able to make misuse that corresponding data. And then you also have elements like web and Android iOS. So if anyone is visualizing that corresponding data on his system, and then he is trying to analyze it, okay, and then perform a exploratory analysis. So at that time, you would be visualizing the data on real time on a web, Android, or on iOS app. So how exactly Internet of Things are related? Now, Internet of Things plays a vital role where you would be seeing that there are different devices, like it might be a mobile phone, it might be different devices which are being connected in. If I consider a smart home automation, what happens is that there are different devices which are out there in my home. I can just take a mobile phone, okay, and then I can turn on my AC. Say, for example, I'm traveling and it's very humid, and before I reach my home, I want my AC to be turned on. Okay, so that's where you can see or build applications like this, where nowadays you also get smart switches, right? So where you just turn on the AC and then you say that, okay, I want my AC to be turned on, and this is a temperature. So wirelessly, via Internet of Things, you would be able to control the devices. The same thing holds good whenever you are working with what is called as self-driving cars also. Now, you might be using a Google Map, or these days, what is called as Internet of Things are deployed on self-driving cars where the vehicle is able to travel in. If time permits, at the end, I can show you the video on Volvo vehicles where the vehicle is automatically drive across. But at this particular juncture also, you can just see that industries are extensively developing industrial IoT, and the data which has been generated, it should very secure so that it doesn't create any chaos, especially when it is working on a real-time scenario of this particular juncture. Now, you would be able to mention the source and the destination data, it would travel and it would reach its destination. The next thing, everyone uses a Fitband. Once you have different sensor data on it, it would tell you based on how many hours of sleep you had, how many steps you have taken, what is the location, say how many hours of gym you had. So all this corresponding data where your health monitoring system is being put or embedded inside a single device, where you can just see that industrial IoT is playing a vital role where the data can be processed in. As far as IoT is concerned, it might be in terms of gaming industry, it might be in terms of any devices we talk about. You can see that IoT is being embedded into devices these days. It might be small plug these. Last day, I was just had a chance to visit the electronic forum expo. So what happened was I just saw a switch which is costing you somewhere around 45 rupees, and you would be able to connect different devices to it. It has a Wi-Fi module on it, and then to that switch you can, if you have internet connections in your home, you can connect different devices and then control it. So it need not be only mobile phones, smart watches. These days there are sockets, bulbs which can be monitored remotely using the IoT technology. Now, when we talk about deploying these technology on the cloud also, that's also one of the challenging area where these devices are to be connected to cloud, and at the same time, you should be able to analyze them, give prescription based on whatever health monitoring algorithms which are out there, or it can be directly connected to a doctor who can actually analyze your data and then give you suggestion based on whatever data which you're generally working with. To take this further, you can just see that these chips, whatever we develop in, are being put into latest phones these days. If I talk about iPhone, they every time whenever there is a new phone which is being released, you can just see that they come up with the IoT and machine learning and AI concepts which are out there, where you can have different applications inside the phone, or it can be in terms of meeting your targets or setting up your calendar. You can just see that IoT is playing one of the vital role in terms of modeling various technology. As far as data is concerned, each person would be storing large amount of data into the cloud, and this is where the whatever data we write it into the cloud. Generally, the question is: are these particular data safe there? Yes, because there are set of engineers, especially you can just see that there are few startups who are actually working on this area, which we call it as rooftop technology, uh, where they develop algorithms to safeguard this particular data here. Okay, basically, this data, whatever is there in the cloud, okay, to safeguard that data, it might be your Google Photos also. Okay, so there are algorithms which are developed so that this corresponding data is being safeguarded. So basically, whenever the data is stored in terms of chunks, or it might be in the cloud server, you generally see that we have options where we can monitor this kind of data and then process it on a real-time scenario. Okay, it might be uh, say booking a hotel, or it might be traveling from one destination, or using a mobile phone. You can also have these days like Kia Carnival. If you look into that vehicle these days, using your mobile phone, you can obviously turn on the engine. Okay, the automatically the engine would turn on, and that connectivity is also given to the smart watch. So whenever you go ahead and purchase that, I'm not talking about technology which is outside India. I just prefer talking things which are inside India. Okay, so that's one of the vehicle which has a smartwatch where you can just switch the turn on the smartwatch and then click certain options there. It would turn on and turn off the vehicles. Okay, and at the same time you can monitor different parameters of your vehicle in terms of that smart devices which are generally using it. So having said so, you can also monitor it like an industry where there is a packing system, and then you can also analyze this. So this is where Amazon is extensively working on. Nowadays you can just see drones. If you go to YouTube and type like drone based Amazon delivery, you can just see that drones are actually delivering the goods these days. So in UK and US, and it's already functional in UK and US, where the drones have been generally used to deliver the packages to the destination. Okay, so you can just analyze like what is the data which is being captured in terms of a small mobile phone which is being available in your hand, and then you can analyze the specs of the AC which is out there, and then you can say that yes, go ahead and perform an inventory of whatever product which was manufactured, and in terms of interaction, all those data you would be able to capture. So once this is being done, you can directly load those into the vehicles, and then you can send those devices into their destination. As far as the business insider is concerned, you can just see that Internet of Things would raise up to somewhere around 24 billion, okay, by 2020. And then this is what is the prediction. So somewhere, as far as the IoT revenue is concerned, it would go up to more than, or it would reach this numbers. Okay, that is in terms of dollars. Okay, so this is the IDC predictions based on the IoT revenue which we are generally talking about. So whenever you talk about IoT, okay, it might be in terms of normal banking technology, or it might be retail market, healthcare, or it might be in terms of communication. All these areas you talk about, you would be seeing IoT, and then you would be able to generate huge amount of money. Okay, it might be in terms of crores together. Okay, and it would also generate huge job opportunity in this particular area. Now, as far as the overview of IoT is concerned, that was the overview of IoT. Now we'll get into the technology aspect of it. Okay, now as far as the existing technology which we are having, the first one is called as direct interaction pattern. Okay, so you would be having one IoT device where you would be directly sending the data into the cloud. That's first thing. Okay, the second thing is gateway integration pattern. Say for example, you have a camera, okay, or you go to FASTag, right, or you travel in a car and then you have a FASTag in it. So as soon as you reach the destination, okay, the toll booth, the amount gets deducted, okay, because there is a gateway which has been there, and then these are the things which are the barcodes which are out there in your vehicle, and using the gateway, the data would be sent to the cloud. The gate, I mean, the toll gate would open and it would close. Similarly, you also have what is called as cloud integration pattern. Okay, where you have a cloud and things can directly be connected. Two multiple things can directly be connected. So this was after what is called as the ESP8266 module, which came to market, where you can directly connect different things to the cloud. Or this, I can give you a simple example of your mobile phone, where there are different sensors which are being connected to the cloud, which we call it as cloud integration pattern. So these are three different existing IoT patterns which we generally see. The emerging technology which we have is, you had a things framework, where you'll be having things like this, and then there'll be a think gateway, and then there will be a think cloud. So basically you would be able to write the technology into the cloud, and then you can process, control, and automate whatever models which you have it. At the same time, this would also have the high-end encryption and decryption of models, where the data, whenever it is being transferred, it will be in terms of what is called as um, mobile agents, and then it would also whenever someone tries to hack that, okay, so it gets destroyed by itself. So what is that? We'll just come, we'll go further, and then we'll discuss on that aspect also. Now this talk brings me, or this previous slide brings me to a new protocol. We call it as LoRa. Okay, so it is called as long range communication protocol. Okay, so you might have seen devices which can transmit data, or it can capture data, but whenever you talk about LoRa, it is basically long range, and it can go up to 3 km in urban environment, and then 7 km in especially rural environment. Okay, now once this is being done, you can also see that the power consumption is very less. As far as basically these devices are concerned, previously we used to have passive, what is called as battery operated models which are out there, and then they have a secured communication. Then there are open source platforms also, where you can easily access the data on real time. So the added advantage of LoRa is that, one thing is that it is long range. Basically wherever you place it, you would be, it might be in terms of visualizing it on a Google Map, or it might be on say the maps which are out there which you have created by yourself. So you would be able to do that. As far as the vehicle technology is concerned, I think we also had Chandrasekhar Gale last day. He extensively works on developing maps, okay, for the ADAS vehicle. So whatever roads we travel in, right? So they capture that corresponding live feed of the, I mean, road, and then they convert into a virtual environment. That means a graphical environment it will create. That scenario is basically used to test whatever vehicle which is out there. Okay, so that's with respect to the ADAS. As far as multi-usage is concerned, you can just see that it has a high capacity, and then as far as the cost is concerned, nowadays LoRa is one of the technology where most of the colleges as well as industries are setting up center of excellences in IoT. That's basically using the LoRa technology. So what happens in LoRa technology is that you would be having LoRa nodes. Okay, it might be what is called as an Arduino board. Okay, for which you would be connecting different sensors. These are called as your nodes. Initially, I started up with different sensors. Like it might be an humidity sensor, temperature, pressure, or it might be the GPS sensor or different actuators which are out there. These things would be connected to what is called as the devices like this. It might be a normal Arduino board, okay, and then these would be having antennas also, okay, where via which they would be transmitting what is called as signals, and they can also receive the signal, transmit as well as receive, and then these particular nodes are also called as your LoRa nodes. And once this particular signals are being transmitted, you'll be having a router kind of structure, which we call it as gateway. Okay, in the previous slides, I was just mentioning about nodes and gateway, right? So this is the gateway, which can capture somewhere around multiple nodes, which can be connected to it. And then via that corresponding LoRa gateway, you would be able to write the data into what is called as the IoT server. Okay, so to this particular network, we have something called as uh, different channels which are out here. Okay, so let me just keep it like this so you guys can see that. Oh, I'm sorry. Okay, so anyone who wants to work on IoT, what you can do is that just come down and search for ThinkSpeak. Okay, so this is one of the company which was acquired by MathWorks. Okay, so this is called as Think uh, Speak. Okay, so this was one of the company which was a startup, and I think 2 years back. Okay, 2 years back, this company was acquired by MathWorks, and I mean the MATLAB software, whatever we generally use it. And here you can just go ahead and you have commercial use also, but uh, 1 month, okay, or I mean up to 33 million messages, you would be getting the free version also. So what you have to do is that you have to go here and then uh, create an account in what is called as ThinkSpeak, where you can develop applications in terms of checking the air quality, or it might be ThinkSpeak energy monitoring, where you have solar panels and then you want to measure the energy, okay, and visualize the data on your mobile phone, like today what is the amount of electricity which is being generated, or it might be in terms of smart farming, where you can collect, analyze, and act based on whatever data which you have captured. Okay, and then there is one more what is called as network. I think it's uh, think, hmm, yeah, things network. So this is also one of the a place. Okay, if you see, I have I have what is called as accounts in both these. So this is where you will be able to build a LoRa WLAN network. Okay, so it might be in terms of self-driving cars, or it might be in terms of what is called as cattle tracking, smart irrigation, or smart parking. So such kind of technology where you can develop it from start to finish. So where you can come up and build applications. You need not be an expert, okay, to actually develop and build applications here. Once you spend some time, you would be able to integrate and build different uh, what is called as uh, applications based on your requirement. So you can just see that it can integrate on a stack server, and then it can be having an application server which can have HTTP or Amazon, AWS or Azure, Google Cloud. So all these can be customized based on whatever models which you have. Okay, so this is two websites which you can just look into. One is called as Things Network, the other is called as ThinkSpeak. So anywhere you can just go ahead and write your data on real time. So let me just minimize this. So where we would be able to visualize the data on real-time scenario. So LoRa applications, if you see, it might be in terms of smart cities, or it might be in terms of smart parking, uh, what is called as smart street lighting, or it might be in terms of smart water management, or environmental monitoring. So you talk about these technologies, you can just see that LoRa IoT approach is playing a vital role. As far as other applications are concerned, you can just see these are few of the applications which have been mentioned in where you might be developing smart precision agriculture, or it might be smart industry based boiler points, boiler plants, or it might be in terms of geo location tracking. So basically, you can just see that LoRa is being used there. So this is a small gateway where you can develop different kinds of applications. It might be in terms of smart intelligent plant, or it might be in terms of smart farm and so on. So one such technology where you can just see that this was one of the application which was developed in Tamil Nadu. Okay, this is for smart irrigation system where based on the wetness content, the motor would automatically turn off, where the yield was doubled, and it was able to maintain the precision in such a way that uh, generally what happens in the certain field, okay, certain part, if it was dry, okay, you can just it would analyze that, and then it would be able to what is called as turn on the motor and turn on the sprinklers only in those corresponding directions. So such kind of deployments can be done. One such project, what we had worked. So people from aerospace engineering, they would have understood what is this. So this is a aircraft simulator. Okay, now the aeroplane, okay, it will be flying in space. I mean, so there would be different parts of the aeroplane, okay, which would be tested inside this particular chamber here, where they would be bombarding it with say uh, uh, different speed of air. Okay, so you can just see that there is a turbine here. So inside this, how exactly the temperature varies. Okay, so imagine this is a big chamber. Inside this, they will make the different parts, okay, parts of aeroplane tested inside this, and check how exactly the stiffness is behaving, how exactly the vibration parameter is there, okay, at different wind speed. So here you have the aerogen, so that would be feeding a huge amount of what is called as air, or it will blow air at a faster rate. Now the same device, so this is one of the project which I was completely, I mean, the end to end was done by me, where we had developed an IoT and uh, uh, setup inside this, where we were capturing the data into the LoRa device, and then we were projecting that on a network. Okay, so how exactly to do that? Let me just go ahead and then demonstrate it. So for demonstration, what I would be using is, let me just go ahead and clear. I think let me just clear this. I think everyone have worked with MATLAB, so I'll be using this. So my variables are cleared now. Okay. Okay, so let me just demonstrate the first code to you. Now I have a live camera, okay, which I have connected it to my laptop. Okay, so you can just see here, if I come here and then say webcam list. Okay, so it will say that yes, Pramod, you have, I can keep it bit here. So you can just see that there is a webcam, that is a webcam C170. That is a webcam which you have connected into your system, is what it's mentioning. Now once this is being done, let me just clear everything. And then what I'm trying to do is that I have a think speak read. Okay, what I'm trying to do is that I have the camera. Okay, from the camera, okay, I am initializing the what is called as data. Okay, where it will count the number of faces. Okay, generally, if there is a conference going on, if it was a live conference, we what would have done is we would have deployed this exactly at the entrance, and it would have captured the people who are attending the conference live, and then we can also embed the attendance system. So there is no point in taking attendance and sending feedback. I mean, feedbacks, I think we can give it as a link, but it can automatically take the what is called as attendance, and it can project that data into the cloud also. So such kind of things you would be able to do with this. So where we are writing the data into ThinkSpeak. Okay, so ThinkSpeak app, you can go to Play Store and download that. So this is the channel where I will be writing the data. So to do that, let me just again come back here to my web page. Okay, so you can just see here. Okay, so this is the first page. Okay, and uh, think speak network. Okay, here if you have a account, that is, you can just click on this and then you can create an account. Okay, so I have already an account, so I have logged in into my account here. Okay, and each person would be able to, once you go into my channels, once you log in, you can just see that you would be able to get into your channel. Okay, so this is your channel where Mathworks will allow you to create 3 different channels like this. Okay, and then once you have created channels here, you would be able to what is called as write the data into these channels which have been out here. Okay, so if I just go here and click on one of the channel here. Okay, so you can just see that the channel is what is called as uh, whatever you have written here. Okay, in the program. Okay, in the program you have said ThinkSpeak 307920. So this is the channel read. Okay, a read key which you have mentioned. And then what you're trying to do is that you are mentioning the channel read key also. Now if I go here, okay, so you can just see that that's one of the channel. I can just come back, check what is this channel number. Okay, and this channel here. So I have the channel key, and where I would be able to capture the data on real-time scenario. Okay, so let me just go here. So this is how the channel would look like. Okay, so this is the channel which we are having it, and in the channel you can see that it will give you the location, and then it will also give you what is called as the public view. Channel settings are there. Okay, where you can go ahead and then mention the different channel. Followed by that, you also have the API keys. Okay, so you can just see that to write the data and to read the data. Okay, so you would be requiring these API keys where you would be able to write the data, and then you also have the API requests where you would be able to write the data into these particular channels here. Okay, so one is your channel ID. Okay, so what I can do is that let me just copy this and come down to my code here. Okay, I can just go ahead and say control V. Okay, and read key. Let me copy this and come down to MATLAB control V. Let me just run this. So to that channel, what we are trying to do is that we are trying to capture the live photo. So you can just see that it is telling 436, right? So continuously, like you can just go ahead. I don't have a photo, or else via mobile phone I'd have shown some photos here. So it is capturing the live data of my face, and then let me just close it once. 437, 438. So like that, on live after 5, so fifth person, it will say that you are the lucky winner of this corresponding session. So like this, you can go ahead and give some goodies where it is capturing the live data, and this particular live data would be written into that corresponding cloud setup. That's your ThinkSpeak channel, whatever channel ID which you have mentioned it. So let's go into the code fast. So you are having a webcam where you're telling that this is a webcam and this is a resolution of it. And these are the channel read keys where you are writing that corresponding data. And then whatever camera is capturing the video, it would be in terms of 640 into 480. And then you would be capturing that data and converting that into a frame. And then once that is being done, you would be creating a logger where it will be able to write that data into the cloud, and then you can visualize that number also. So we said that iterate until we successfully detect the face, and then you are mentioning a loop also where you're telling that okay, every fifth frame you should say that he is a lucky winner. So it will say that after every fifth frame it will convert it into nums and string, and then you are displaying that where the fifth winner after every fifth what is called as data, it would be capturing that corresponding thing. Now let me just go ahead and close this. Yeah, and that same data would be written into the cloud here, right? So I can just come into my view, and you can just see that the numbers. Okay, so you can just see that August 2nd, 2020. You can just see that the data, whatever we just captured now, it is updated. So you can just see that the maximum value 434. Okay, so 434 faces it has captured. So like this, you can write the data where it can also show you the field. Okay, and then as far as the security is concerned, this is the API keys which you can obviously just one. If you just click on this, it would obviously generate keys by itself, and it takes care of all the encryptions, where you can make this particular setup public and then visualize various data on real-time scenario. You can also import that in terms of an Excel sheet too. So whatever till now data we had, you can import that into an Excel sheet. Followed by that, you also have certain public channels here, okay, which you can just go ahead and view. And then you can also create what is called as an think what is called as tweet. Okay, so Twitter, you can link it. So you can just see that you have linked a Twitter. So when it reaches a certain stating that hi bro into my mobile phone. So when you can just see that I showed you the mobile phone, right? So in the mobile phone, as soon as I logged in, it gave me that yes, Pramod, once you have closed the window, 434 members have attended. So like this, you can set up a ThinkSpeak connectivity. You can also have reaction also. Say after a certain time, I said initially during my presentation, you can turn on, turn off the devices where you can connect it or create a reaction based on certain number or certain temperature, or you can also have a talkback, okay, where you have Alexa and all, right? So you can just have a small Arduino board and a talkback speaker to it, where you can go ahead and communicate to those devices, okay, remotely, and then control them also at the same time. So this is what the technology which we are talking about, and this was one of the demo, and the second demo I'll just show you as we go further. Okay, now this was the first part where we just captured a live video where we counted the number of people and then we loaded the data into the cloud. Okay, so like this, you can also develop different applications where you can use devices like LoRa products. It might be in terms of indoor or whether you want it in outdoor. This is how the Arduino based shields will come. Raspberry Pi shields are also there when you have high-end applications. You can also have different kinds of sensors, okay, which can help you in monitoring different things. As far as open source range is also concerned, you can just see that these are the technology which is playing vital role, where the encryption, as far as the cyber security part is concerned, you can just see that this is where end-to-end encryption takes place, where you have devices, okay, which are operating at somewhere around sub gigahertz RF frequency ranges, where you would be two different uh, say encryptions which we generally use in when it's called as network session key, and then we also have something called as application session key, which would be used to what is called as deploy your algorithms on cloud, where the IP is also secured, and at the same time in the cloud also you saw that there is a read and write API key. With a click of button you can go and generate new keys out there also. And further than that, on the cloud also there is a technology called as rooftop, which would be used in where end-to-end connectivity of devices is out there, where the data from application to the device or the device server, you would be able to do it, where it might be in terms of IP to IP connection, and from the network server it is connected to the application server. Okay, so like that you would be using this corresponding data, where you can just see that the network session key as well as the application session key would be the encryption which would be followed. Now, what kind of technology you can develop in? This is for more demo which I was talking about. You can just see that there is a LoRa based weather station which is in US, okay, and we would be capturing the data from any time domain, and then we can also visualize that data, the location, humidity, pressure, where you can just take a small setup of somewhere around 3 to 4,000 setup you can have continuously. That should have power supply. Until there is power supply on that device, it would be continuously sending the data into the cloud, whatever cloud I just showed you. You can use ThinkSpeak or Think Network, and that you mentioned in your program, you would be able to write the data. But in this case, I would show you how exactly you would be also capture a data from what is called as a public, what is called as channel, which has been out there in the cloud. From that you would be able to explore, access, and then using that data you can develop perform data analysis, and then you can come up with your own ML AI applications which can be directly deployed on the smart devices which we generally see these days. Okay, so for that the setup would be like there will be an Arduino board, there will be two uh, what is called as LoRa nodes, and then it will be put up on a weather monitoring system with different sensors. Okay, so to go to that, let me just come down here. I can just go into IoT. It's there. Yeah. Yeah. So this is what is called as a read key. That is the channel ID is given, and then you have the read key which is from the cloud. So if I come down to the ThinkSpeak here, okay, so these are channels, these are my channels, okay, and then there are public channels also. So public channels, basically these are the channels where you can create your own channel, and then you would be able to continuously send the data into that corresponding channel. Okay, especially Kerala, Tamil Nadu, if you want to monitor monsoon, okay, predict weather, okay, such kind of projects would be really helpful uh, to the humanity, and uh, a lot of people in Kerala are working in that area. Okay, just wanted to point it out. So if you want to monitor a weather station, okay, so if I go to this channel here, okay, so you can just see that it is 1237. Okay, so this is the data which is out there. Okay, from this data, okay, it will show you where exactly the node is being placed and what are the different parameters you are able to measure. Okay, so humidity, temperature, rain, pressure, power level, lightning intensity. So like that, you would be able to visualize this data on a real-time scenario. I'm currently sitting in Bangalore and I'm monitoring the Boston NATIC office data on real time. Okay, so that can be also imported into your MATLAB session. Okay, so for that, basically, you would be requiring the channel ID, the read key. Now, whatever ThinkSpeak, which I just showed you, it had the live data. Imagine I want the data from 2017, okay? And this is the date which I mentioned there. I say that I want to read the channel data, and then I want to project that in terms of a figure. So once I have read that, okay, in terms of various fields, so under that there were different fields. Okay, so when I run that particular first half of the section, you can see that it has captured analog temperature. That means there was a sensor which was measuring temperature, light, humidity, uh, and then if it was pressure, we would have assumed that it is TMP, oh sorry, DHT11 or DHT22, right? So those are the ICs they might have used in, or sensors they might have used in. Then you have heat index, pressure, altitude. Okay, so like that there are 8 fields, and that is what you're telling it. So channel ID is this. From that, from this date to this date, that is from 25th April 2017 to this date, you have to capture data. Okay, and then you put it table. Okay, so that is what you have done here. And then you say head of T, it would display the data which it has captured. Now, if I go ahead and instead of viewing this like this in terms of temperature, humidity, pressure, it's ideal that I just go ahead and then plot that. Okay, so this is how the plot of that corresponding data would look like. Okay, let me just run this. This is the plot. Okay, okay. Yeah. I think I have to press escape. It's not allowing me to move. Okay, fine. So you can just see that this is my figure 1. So whatever that data which we just captured, you would be able to see that data in this particular format, which is very shabby. So instead of that, what I do in my plot is that I just say that, okay, whatever this chart is there, you plot them in terms of subplots. Okay, so where you say that all that 8 fields, you plot them in terms of a subfield and then display that corresponding subfields. Okay, so once I go here, that figure would look somewhat like this. Okay, so you can just see that you do the temperature, light, sound, and various other parameters. I don't know what it's giving a problem. Yeah. Because at the top here we have this one, right? So it would be very difficult. Anyways, so that was the plot which we captured in, okay, with respect to temperature, humidity, pressure. But I just wanted to analyze that. Yeah, so you can just see that this temperature, okay, somewhere around 12 to 14, okay, that is around 12 p.m. to 2 o'clock, the temperature reduced. Observe light, observe humidity. So that also has dropped. Okay, and then there is pressure, amplitude, altitude, temperature in terms of IPS. So this is your analog temperature. This is in terms of the digital parameter which they have captured. Okay, and then that's not the code all about. It also applying filtering, and then it has to identify like sound pollution. Okay, for that we have given 2 timestamps, and then identifying the peaks. Okay, peaks means at which peak the sound was maxed. So it has identified that there are total 12 peaks during this particular duration, especially if it is in the morning, whatever time duration you want, you can just mention that. So during that time, the sound pollution parameter also it has projected it in terms of a graph. So like this, you would be able to build models based on whatever model which you have created. Okay. So similarly, okay, similarly, you can also come up with vehicle tracking. So you have to place a camera at an higher altitude, and then you did not write any code. Okay, people from mechanical engineering, if they are attending the session, they this would be one of the model-based design which sir was mentioning in. So where you can place a camera at an higher altitude, count the number of vehicles. Okay, so the such kind of applications also can be done in where you are placing a camera, and then this application is running on a Raspberry Pi. Okay, so you just saw that this was the board. This is the camera which is being used in, which is being connected to the Raspberry Pi, and then you develop the algorithm like this, where these blocks would be already available. Bob analysis and force background detection and Kalman filtering we apply on it, where the Bob analysis would count the I mean determine the vehicle, and then it would also increment at each and every count, and then you can directly have a Simulink block where you can directly write the data into the cloud. So there is an S function where you can also go ahead and create your own blocks also. I think people who have worked on it, they would be aware of it. So IoT is basically you have nodes, you can integrate the data and then analyze and develop an application. So application might be like there is a juncture where there is a signal. Okay, Trivandrum junction there is a signal, and then on all the four directions there are these signals which can be turned on or turned off. So such kind of applications where the number of vehicles are more, only that side the green light should be on. Okay, so such kind of applications students can develop in, okay, which can be for project and which is associated to IoT. And as far as industrial application is concerned, so this is one of the case study where you can just see that the real-time cloud-based commercial building owner where they were able to reduce what is called as power consumption. So the data was analytics use was done for 3 to 12 months, and they were able to apply machine learning and come up with an application which resulted in 15 to 25% of overall electricity consumption of that corresponding HVAC. So such kind of applications on real, and then you would be able to write the data into the cloud, visualize and come up with various solutions. Okay. To wind up with my session, so this was one of the video. I think everyone might have seen this. So Apple series watch video. I just if you want, I can just play this. But I think because of the time constraint, let me just go forward and uh, say thank you for everyone. But uh, let me also go ahead and take up any questions there, because in the chat I can see there are 12 questions. In the meanwhile, I think let me just go through the question, watch this corresponding video. Yeah. So that's it. Questions. Okay. I think there are no questions. If there are any questions, we can take it up. If there are any questions, you can just put it in the chat box. I would be happy to address those questions. Are there any questions? You put it in the chat. I would be happy to. Thank you, sir. Thank you.
The questions were put up in the chat box also, if there are any.
Thank you. Thank you. Thank you. Thank you. Yeah, the relationship between Docker basically here, I mean, especially when whatever applications which I showed you, you would not be using it, but if you are planning to go ahead with that, you can obviously link it. Okay, so Docker, you can actually link it into whatever IoT applications which you are trying to build in. Yes, you can do that. Yes, you can do that, Docker. So uh, especially whatever IoT applications which we demonstrated, like it would be, as I said, we are not using it for self-driving cars. I said IoT 3D. The reason for that statement is that if you're using ThinkSpeak, okay, so every 15 seconds, it would take to update the data there. Okay, but imagine you're traveling in a car and it takes 15 seconds. So that's the reason LiDAR and radar are being placed on the self-driving vehicles. So if you are trying to have a Docker container, then you can also increase the speed and the security wise and in terms of application, you would be able to connect it. Yes, connection is possible. Yes, 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 it is possible.
Any more questions from the participants?
Yeah, just go ahead and then say LoRa. You would be able to get how to connect it also. It's already there in the net. But obviously, you can reach out to us. We would be happy to give you the details. So you can obviously send us a detail here. I can share you the doc how to connect it. There's a, I mean, if you just go ahead and type LoRa IoT, you would be able to see that.
Yes,
This
sir.
is where you can reach us.
Thank you, Pramod, sir. So on behalf of Department of
Thank you,
Mechanical Engineering, Tkmce College of Engineering, and as a coordinator, and also on behalf of all the participants, I sincerely thank for all the efforts and also for taking a wonderful session,
Thank you, sir.
especially in a very recent advanced area, IoT, very interesting area. So thank you so much, sir, for being with us.
Thank you.
Thank you, sir. Thank you so much.
Thank you, sir.